Let's look at our first type of matched pairs design. So this is for cholesterol medication. Researchers are interested in the effects of Lipitor on LDL cholesterol. 12 people had their LDL cholesterol measured at the start of the experiment and then 12 weeks later after taking Lipitor daily. Right, so this type of matched pairs is a before and after. We have 12 people, 12 subjects. We only have one treatment that we're doing here, so just the Lipitor. Everyone's getting it. And then our response variable is going to be the difference in the cholesterol level. Okay, and then for the blinding, there's no placebo mentioned in here, and there's not really any information to indicate that there's any blinding. Typically, blinding in a before and after type of experiment, or also this multiple levels of this medication, would be a much more sophisticated design that you would cover in a more advanced class. So we're going to stick with just the basic designs. There's no blinding, and everyone's going to get the same treatment. All right, so the diagram for this experiment, we're going to start with our subjects, the 12 people. And then our organizational technique is just going to be to split them up one person per line here. They have person 1 and person 12 at the bottom. And I'm just going to go dot, dot, dot down the middle because all of these rows are going to be the same going across. All right, since this is only one person, there's no reason to split them into groups. So we'll go straight into the treatment, which is the Lipitor. And everybody in here is going to get that. So we'll go dot, 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 and then we'll put a Lipitor for person 12. And then the response variable that we're measuring for each person is going to be their difference in cholesterol level. Okay, so whether their cholesterol level got better, got worse, stayed about the same for each person. And then we're going to compare all 12 of these people together to see if there's a majority of people who improved with this medication, stayed the same, or got worse. So we want to see if we can find some trends or patterns there to kind of inform what we want to do next with our research. Okay, so there's your basic before and after matched pairs. Let's look at a little bit different version of a matched pairs. This one's called grocery stores. So researchers recruit 20 grocery stores to participate in an experiment to compare the effectiveness of two methods for displaying a product, method A and method B. Okay, and it's a pretty normal thing for grocery stores to get these displays from the manufacturer. So this is something that a grocery store would be accustomed to dealing with. The stores are paired in groups of 2 based on similar weekly sales. So what that means is we might take 2 warehouse stores like a Sam's Club and a Costco, and we would pair them up. We might take kind of 2 regular grocery stores, so like a Safeway and an Albertsons or something like that, and pair them up. So they would all be paired kind of based on similar sales and similar, I don't know, size of the store, things like that. All right, at the end of a week, the researchers will count the number of items sold. So this is a traditional matched pairs in the sense that we have a pair, and we'll assign one part of the pair to get method A and the other part of the pair to get method B. Right? Our subjects are the 20 stores. And our factor is the display method. And our levels are A and B. And then our response variable is the number of items sold. And they don't state this in the problem, but I'm going to add this on here that we're going to randomly assign each store in the pair to get a display method. Right, blinding. Blinding isn't discussed in the description that we're given, but if I were doing this experiment, I would want to make it at least single blind, meaning that I wouldn't tell the stores that I'm testing a difference in the display method. The stores are used to receiving these displays, so it wouldn't be out of the ordinary to send them to them. And they don't need to know that another store that's similar to them is using a different display method. Okay, and part of the reason for that is that when I worked at Costco, the cashiers were always in a friendly competition over something different. So one week it was who can sell the most bags of ice in the week as a cashier. And so that meant that every customer that came up, the cashier said, oh, do you need a bag of ice with your groceries today? Right, so we don't want anything like that influencing the results of our experiment. So I would definitely make this single blind if I was the experimenter. All right, for the diagram, we're going to start with our 20 stores. So I'll put those down here. And then we're going to pair off these stores in groups of 2. So I'll have pair 1. And then it'll take all the way up to 10 pairs. So pair 10 is my last one. Okay. And then this is my organizational part. So I'll go dot, dot, dot. But there's no random assign because these 2 stores are equivalent or they aren't equivalent. So that's how we paired them up. Then I am going to randomly assign them out to get either treatment A or treatment B. And what I need to do is I need to identify which member of the pair is getting which treatment. So I'll call this pair 1.1. So whatever was the first store I pulled out of the hat for that pair. And then the other one would be pair 1.2. So the second store out of that pairing. You're welcome to use whatever kind of naming convention you would like there. And then they randomly get assigned. So maybe pair 1.1 got display add B, and the other part of that pairing got display add A. Okay, we'll do the same thing with the last pair here. This will be pair 10.1 and pair 10.2 that are randomly chosen. And maybe this one gets A and that one gets B. And then within each pair, we want to compare the number of items sold and see which one of these strategies worked better, whether it was A or B within each pair, or maybe they were the same. That's always a possibility too. And then we want to do an overall comparison among all the pairs. Okay, so maybe one of the display methods works really well for all the stores. So maybe display method A is the one that sold the most at every single store. Or it could be that the smaller stores display method B works better, and in the larger stores display method A works better. Right? So we would want to compare all of the pairings so we can see if there are any patterns or trends or other things like that that might help this company decide what's the best way to sell the most of their product possible. All right, so that is our second type of matched pairs. That's a very traditional pairing.